Hello, today we are going to learn how to solve rational equations using a specific method. We're actually going to look at another method as well, but there's one that I want you guys to practice more so than the others. So that method is to multiply all the terms by the LCD to clear out your fractions. Once you have your fractions cleared, you can solve regularly, and then at the end we're going to check for extraneous solutions. Alrighty, let's get started. We have a rational equation, 4 divided by x plus 3 is equal to x. So let's clear out by multiplying by our LCD. Our LCD in this case, well, we only have one fraction and the denominator is x, so we're going to multiply everything by x. If I multiply this by x, I get 4x over x, which would reduce to just 4. If I multiply 3 by x, I'm going to get 3x. And if I multiply x by x, I get x squared. Alright, now all we got to do is solve. But before we do that, we've just eliminated a denominator, which means we've eliminated a restriction on x. What was the restriction initially on this? X cannot be equal to 0. So let's keep that in mind as we go through. Okay, I'm going to subtract everything from the left and move it over to the right. So we're going to have 0 equals x squared minus 3x minus 4. And when we factor that, we'll end up getting that x minus 4 times x plus 1 is equal to 0. So our x values are -1 and +4. Alright, now, this quadratic has two solutions, but we need to make sure that those solutions would work with the rational equation up top. The rational equation up top has a restriction that x cannot be 0. None of the solutions we got are 0, so this ends up working. Yay! Alright, moving on to a second type of equation. It's a rational equation. This time there's two fractions, but the denominators are the same. So the LCD, because the denominators are the same, is just going to be what that denominator is, x minus 2. We're going to multiply everything by x minus 2. Okay. When I multiply this fraction by x minus 2, and x minus 2 multiplied on the top will reduce with the x minus 2 already in the denominator, because they're the same factor, leaving me with just 5x. I multiply -7 by x minus 2. Nothing reduces because it's not a fraction. Multiply this term by x minus 2. I'm going to get 10x minus 2 divided by x minus 2. The x minus 2 will reduce, and I'm just left with just 10. Okay, let's expand this out. 5x minus 7x plus 14 is equal to 10. Oh, let's go back and make sure we remember that. We went from a rational equation to what's going to end up being a linear equation. We had an initial restriction on x. X cannot equal 2. So let's keep that in mind as we go through the problem. Okay, let's combine our like terms. This is going to be -2x, and let's subtract 14 from both sides. We're going to get -4. Divide by -2, we get x is equal to 2, which looks like a solution. This is why this is mega important, because if you look up, the original restriction on the equation is that x cannot equal 2, and that's the solution we got, is that x is equal to 2. Well, if x can't equal 2, then that means this cannot be a solution. And if this is the only solution we found, then that means that there are no real solutions. Okay? That is your answer. There's no value of x that would satisfy this equation. Alrighty. Let's look at this next one, which we're actually going to solve two different ways. First, we're going to actually clear by multiplying by the LCD. Alright, to find the LCD, let's make sure our denominators are factored first so we can get a good idea of what the factors are of our LCD. This is x times x minus 1. This is just x minus 1 equal to 0. So our LCD is has to have an x, has to have an x minus 1, and this is already represented in the LCD, so we don't need to add it again. We're going to multiply everything by x times x minus 1. If we multiply this fraction by x times x minus 1, remember, multiplying a fraction by something just goes in the numerator. So we're going to have x times x minus 1 in the numerator, x times x minus 1 in the denominator. That's just going to reduce to 2. If we multiply this fraction by x times x minus 1, we're going to have x times x minus 1 in the numerator and x minus 1 in the denominator. The two factors of x minus 1 are going to reduce, and we're just going to be left with the x in the numerator. Alrighty, and multiplying 0 by anything is nice because anything times 0 is just 0. Alrighty, so let's add x to the other side. We get 2 is equal to x. Alright, does that conflict with any original restrictions? Let's see, the original restrictions on all of the denominators that x cannot equal 0 or 1. And we got that x is equal to 2, which does not conflict with any of the original restrictions. So we're good. Let's take a look at a different way of solving this. Alright, so what happens if we, instead of multiplying by an LCD, because this is equal to 0, if we moved, and I'm actually going to still factor these, move this term over. Okay. Now we have a proportion, a fraction equal to a fraction. We can actually solve this by cross multiplying. Again, let's keep in mind that my x values cannot be 0 or 1. So if we cross multiply, 2 times x minus 1 is 2x minus 2. 1 times x minus 1 is just x times x minus 1, which is this. Alrighty, let's subtract everything from the left side, bring it on over to the right side. So x squared, we're going to subtract 2x from negative x, which is negative 3x, and add 2 to both sides. Alrighty. Let's factor this guy. It'd be x minus 2, x minus 1 would give you that. So x is equal to 1 and 2. Well, hold a sec. Hold on. We got x is only equal to 2 here, and we got x is equal to both 1 and 2. Same equation. How is that possible? Notice that our restriction above says that x can't be 0 or 1, and 1 was one of the solutions that we found. So that's not a real solution. The only solution that ends up working is x is equal to 2, which agrees with the solution we got on this side. Okay. So once again, clearing your fractions by using an LCD, that's the way that I usually go. Always check for extraneous solutions. As soon as you get rid of a denominator, you need to remember that your x value cannot make that denominator 0. Otherwise, you'll get extraneous solutions in your solution, possibly. And that is how you solve rational equations.